You're looking at the logo identifying an intriguing software program created by our guest, Dr. Dean Dauger, the president and CEO of Dauger Research, which is headquartered in Huntington Beach, California. This is a company that specializes in high-performance scientific and cluster computing. We've learned a little bit about what cluster computing is now. Now we're going to have an actual demonstration to see how effective this program is, how simple it is to use. Now, Dr. Dauger, and also obviously here with me is Kevin Sinclair, who's the Vice President of Operations for Dauger Research. Welcome again.
Thank you.
Tell me a little bit about, and show me a little bit about it, actually how simple this program is to use.
Okay.
And we should repeat and reiterate the fact it involves linking multiple Macintosh computers together to, in effect, build a supercomputer. Mm-hmm. Okay?
That's right. So, I usually like to start
with... And what we have here, by the way, what we have.
Sorry.
Right down here next to our desk, you have a Mac laptop on the desk here, and down underneath us is a G5 computer, one of the Mac G5s. Okay.
And we've gone ahead and connected together with a typical Ethernet switch. Just a couple of Ethernet cables, and so that's the extent of the hardware assembly that we did.
This was all set up in just a matter of minutes. Very simple.
That's exactly right. It took no more than 5 minutes to set this up.
That's right.
And we're ready to roll.
And in effect, what do we have now?
Well, what we formed here is a computing cluster, basically a larger computer that's formed out of the member machines that we just joined together here.
Is there a term to use of how powerful this would be?
This would be, well, I mean, in this case, a 3-processor cluster. And we'll get an idea of actually how powerful it is with the benchmark software.
What you're going to show us. All right.
Yeah, that's right.
We can get a shot of the laptop screen here. So let's see what you're going to do.
Yeah,
and how Pooch works.
Okay. All right. So the first thing I'd like to show is actually an example application, something that takes a certain amount of CPU time, and it produces a nice graphical output called sort of a fractal benchmark, basically, and does a z to the z4th iteration, something a little more complicated. I thought it produced a nice output, but it adds up how many floating point operations it does, and times itself to be able to gauge what kind of performance it gets. And it's showing in the upper left there. It's showing 949 megaflops, and this is just using my PowerBook here. If I go ahead and use the vector unit that's in here, well, I wanted to go faster, so I go ahead and use the processor that's here. I get about 5 gigaflops or so. But even if I had a second processor, it could make use of that, but that's only another factor of 2. If I want to get outside the box, if I want to get beyond a factor of 2, I need to use parallel computing, and therefore I need to use Pooch. So let's see how long. Right now, Pooch is not installed, and so here's the Pooch Pro installer. And that I'm going to show you how long it takes to install Pooch on the system. So this is how long it takes to install Pooch.
That's it?
Yep, that's as long as it takes.
It's installed. Wow.
So you can do that on every single machine that you have, on each single node. We identify this as a node and the other machine as a node.
Okay.
And so we can go ahead and say log into the cluster. To be able to create a new job, I select New Job from the File menu, and this opens up a new job window. On the left is a file pane that holds an executable and some input files that will be copied over to the machines listed on the right and launched as a parallel job there. And so I can go ahead and click on, say, Select App to be able to navigate through the file dialog and try to figure out where my executable is. But I really don't prefer doing it that way. I prefer using drag and drop. So how many other parallel computers can you think of that you can launch using drag and drop? There really aren't too many.
You've just brought them together now, at that point. Just that simpler.
So I've included the executable in the job. And if I want to select some nodes, I can go ahead and click on Select Nodes. And then Pooch discovers the other machines that are out on this network and finds out their IP addresses and their names to be able to talk to them and say, gee, if they're running a parallel job, it would show up in red letters as busy, but they're actually okay in this case. And it finds out other information like how much RAM they have and how much disk space they have. Gives and uses that to recommend which nodes are good to run on. But if I want to go ahead and use these nodes, I can just drag and drop some nodes in here. And so now I've selected that. I'm going to combine my other node, my dual processor machine over there, with my laptop here.
Right.
And so to be able to launch the job, all I have to do now is click Launch Job. So the copy executable. If it launches successfully, it barks and reports back, and then it passes control to the Fractal program to be able to report on the performance that it gets. And so what I can see is that it actually cut out the problem into multiple pieces, make the problem, large enough. I'll be able to show a significant performance increase, and it gets about 10 gigaflops. So that's at least that's a substantial performance increase from what I had before.
Well, I can see it worked a lot faster.
Yeah.
I'm not quite sure what all you're saying.
Yeah.
I'm glad it's got all those gigaflops.
Yeah, that's right.
but in other words, by putting harnessing the power of these two computers together, it worked like that.
That's right.
It's what we call BAM power. It's exactly what it is.
And with this, you wouldn't be limited to tying just these two computers together. You'd be able to tie other computers in from anywhere on the internet, basically. So you could use resources, say, in one campus of one corporation to another campus of the same corporation. They wouldn't have to be in the same room or on the same floor of the building.
I mean, that's what seems so fantastic and so amazing, that you can link all of these computers together so simply, really, and harness all of this computing power to be able to, I guess, obviously you're tackling very, very heavy projects, heavy-duty projects.
You have to have a challenging, mathematical, intensive problem that you're going to be tackling. The thermodynamics problems come in, the aerodynamics problems come in, heavy probability situations. Dean worked a lot of physics type situations that required heavy mathematical, intensive applications that required the horsepower per se of multiple machines to accomplish the task.
Dean, let me ask you something. I know this is your baby. You developed this. How long was this in the workings before you really got it figured out?
Well, I mean, we got our start back in 1998, back at the physics department.
You were at UCLA.
That's right. When I was a graduate student there, I worked with a couple of my colleagues there, Victor Desick and Peter Cochlear, over there to be able to cluster this together. We just sort of had this idea. We were rummaging through the features of the Mac OS, and we figured out we discovered these ways of communicating between nodes, and we said, hey, we have these codes that are already running on the big supercomputers like the Crays, the Fujitsus, the IBM SPs, the giant machines of the world. We're already running there. What if we wanted to run them on our own Macs instead? And so we wrote the support software to be able to put this together and make use of it. And that's how I actually did my entire doctoral dissertation, was using the implementation we put together. And other people around the world began to use it, and so it became much more widely used. Even Apple Computer gave us publicity along this line.
I was going to say, what about the people at Apple? How they reacted when they heard about what you were doing? The closed system?
Oh yeah, sure.
Right now.
That's right.
Okay, in my shot.
Yeah, that's right.
But anyway, how have the people at Apple reacted?
They're very enthusiastic. I mean, there's a lot of wows and very happy faces on this. I mean, I have a number of sort of heroes at Apple who were very supportive of what we're doing, and we appreciate that quite a bit.
I mean, really, when you come right down to it, you are building a massive supercomputer at a fraction of the cost of what a supercomputer costs.
Yeah, right. That's a big winner for using Pooch. A lot of these areas that try and get these large supercomputing dedicated resources, you're going to be talking power issues, you're going to be talking thermal issues, trying to cool all the machines. And so this is where you can use the desktops that might not be used at some other times, say in the evenings or on the weekends. And Dean in particular ran into this problem where you have to get in a queue on a lot of these supercomputing centers. And so in a lot of time frames, you don't have time to wait for your queue time to arrive. And so if you have a resource such as this that you can create simply on the fly with resources that you have, it's just going to be phenomenal. You're going to get your job done quicker, and you're going to accomplish your goals faster. And it's just a winner for companies that could be in a crunch like that to accomplish their goals quicker with resources that really work for them.
Now, you're based in Los Angeles. I mean, your company's headquartered in Huntington Beach, but I mean, you went to UCLA. You're near Hollywood. Have many people in the Hollywood community caught on to this yet? I
mean, there are people. There's a number of people who've queried with us. We've talked with. For example, the Home and Garden Network. They wanted to use Pooch to be able to with their video editing software. I have a purchase from MGM Grand in Las Vegas, where they were looking to put together their Macs to be able to do the various kinds of video editing and video overlays that they do over there for like their very big displays in Las Vegas and so forth, and using Pooch to do it.
So it has a lot of applications in the video effects field, but obviously there are lots of other fields that this has huge potential for.
Huge potential, and part of it, and Dean has been working tremendously on creating a whole suite of tutorials to get people familiar with the clustering concepts and get people familiar with how to write code and write applications for even more areas that haven't been explored that could benefit from using clusters and accomplishing tasks that could take hours, maybe take minutes.
Well, I think it's fascinating. I've learned something. Thank you very much. What's next? Pooch 2 coming next?
Oh yeah. We have a version, Pooch Pro, that's
what it is, Pooch Pro.
The Pro version of Pooch, where that's meant for the larger clusters, for clusters that do have, say, one administrator. Pooch Regular is for, say, like one user using his or her own cluster, right, or maybe a few people who know each other, know how to share the resources. Pooch Pro is for people who don't necessarily know how to share resources, and so it has CPU time regulation and so forth.
Gentlemen, thank you very much.
All right, thank you.